Graphing inequalities is the same kind of as graphing equalities, which is normally like the equation of a line is y equals mx plus b. The only difference is, and remember from previous videos, that m is the slope and b is the y-intercept, and you would graph it. Let's do a quick example. Let's say you had y equals 1/4 x minus 1, for example. And again, this is not graphing inequalities. This is graphing normal lines. You'd go, okay, this is my y-intercept, so I always start there. So y-intercept is where it crosses the y. Oh, it crosses y at -1. Looks like it crosses right here. From there, I need to know my directions to my next point. That's what the slope is, right? So this is rise over run. This is, again, previous lesson. So you go up 1 over 4. 1, 2, 3, 4. There's my next point, and I connect it. Now, that's the basis of graphing inequalities. It's almost the exact same thing, except there's a few differences, okay? So now let's change this to, this would be greater than or less than. So before we start, one thing. So let me give you an example like this. Okay, so y is less than 1/3 x minus 2. See how it looks like it's still in the y equals mx plus b form? It is. This is the slope. This is the y-intercept. The only difference is this less than sign implies that we're going to shade an entire region, okay? So let's go draw this graph. So you have, okay, my y-intercept is down 2, 1, 2, make a big point. From there, what are my directions? My slope offers the directions to the next point. So this looks like rise over run, up 1 over 3. So 1, 1, 2, 3, something like that. Okay, now here's where you pause. This is the first difference between graphing lines and graphing inequalities. This sign right here is very important. Anytime you have less than or greater than, your line is going to be dotted, okay? Because it does not include the line. This means non-inclusive. Anytime you have this or this, right, it's less than or equal to or greater than or equal to, that's going to be a solid line. So right here, before you graph, you have to pause, and this is what everybody messes up like on tests and stuff. You have to pause and say, do I have a dotted or a solid line before I even begin this whole process? And looking at this, it's not less than or equal to, it's just less than, so it is absolutely a dotted line. So I'm going to erase this to get this out of here, but that's the point there. So first thing I know is I found my y-intercept, down 2. I found my slope, up 1 over 3. I'm going to connect it with a dotted line. Okay, so this is one more thing that's kind of sketchy. You think you're done here. You're not. I have to shade. There's actually infinite number of solutions. So I have to shade either everything above this or everything below that. And there's a few ways to figure that out. A lot of people teach test points, which is, okay, I'll test any point above it. Like 0, 0 is a point above it, or 0, 5, or I'll test any point and I'll plug it in. And if it makes a true statement, then I'll shade that region. But if I plug this point in and it's a false statement, I would shade the other side. I'm going to teach you a trick. Don't do that. That's like cool and like, it's accurate, but my way is better. If you're walking in this direction, okay, if you're walking from left to right, and I know this video is flipped, so it's going to be confusing, but on your page, when you're looking at math, if it's going left to right, you're hiking uphill, right? So here I am, I'm walking along. If I'm walking left to right, I'm walking uphill, okay? And where is the ground? All you have to focus on is if I'm a hiker, right, the ground is here. The sky is clearly above, and the ground is clearly below. So the way, this is mildly wrong, but I always say it this way, okay? Obviously the sky, heaven, is greater than, the ground, hell, is less than. Pretty weird, but it totally works, okay? So in this problem, here I am, I already have my dotted line, everything's cool. I'm hiking in this direction, I'm hiking up here, sky and ground. It says y is less than, so I know it's not the sky, it's not greater than, it's not heaven, it's down here. And my final step is I come back and I shade everything beneath that point. So it's kind of, again, it's very similar to y equals mx plus b, but there's two issues. One is solid or dotted line, and the other is which side do I shade on. And okay, just to make it so all the math teachers out there don't get upset at my video, I will also show you the test point way. 0, 0 is clearly above the line, so that's a perfect test point. I'm going to plug it in. I'm going to plug in 0, 0. I have 0 for x, 0 for y. So that looks like 0 is less than 1/3 times 0, because x went in for there. That's 0 in for x. And then minus 2. Solving, I get 0 is less than -2. Is that a true statement? Is 0 less than -2? And you know it's not a true statement. Therefore, this point is bad. It doesn't satisfy the equation. So I don't shade up here because this was incorrect, so I shade down here. I don't know, whichever way you like better. I like my little scam, my little trick. It's pretty cool, but the test points is probably the nerdier way to do it, so I'll give them credit there. But that's it. And remember, if you're having a hard time with this at your local high school, you can take it online at Silicon Valley High School, and the credits will be transferred back to you from there.